All right, so here we go. So this one again, I'm going to just encourage you, when you just see one number added or subtracted in the denominator, I think it's useful to start with just taking that number off, because this, I can see I can simplify that to do a p-test on, correct? Last one, it was this one. Let me just look back here. Last one here, after I took this number off, I got to a geometric. This one, when I take the number off, I'm going to get to a p-test. So taking this one number off can usually get you to something that you can figure out what it does. So this has more on the denominator, so this is smaller. And if I cancel, I get 1 over root n, right? Canceling the root n's. Okay, so there's my comparison. So now I'm going to go check to see what this sum does. And I'm just going to rewrite it with the fractional exponent so I can clearly see this diverges by p-test. So therefore, I get that the original diverges by basic comparison test. So notice, I'm writing this for the first time, notice it starts at 2. Why does it start at 2? Oh, right, only because if I started at 1, I'd get 0 in the denominator. So it really doesn't matter. It's not going to make a difference if you putting in, or where it starts at. It's usually just making it defined. Okay, this one again has one number, so I'm just going to rewrite it at the original problem, and then I'm going to rewrite without the number, right? So I'm taking that away. So if this has subtract 2, this has more in the denominator, so there it is, smaller. I can cancel here, so the e to the n's cancel, so I just get 1 over n. And what do I know about 1 over n? 1 over n diverges by the p-test, so therefore, since it's the smaller, my basic comparison test works. N equal 1 to infinity, this one diverges also by basic comparison test. All right, let's look at this one. So again, I just have one number. So I'm going to rewrite this without the number. There's n squared, right? So I'm taking the number off. This has more in the denominator, so that's smaller. So this is the same as saying 1 over n. Oh my goodness, again, yes? So this is summation of 1 over n. And again, I'm just starting at 2. This one's starting at 2 to make sure that the terms stay positive. Remember, we have to have positive term series to do a comparison test on. So this is the smaller, so therefore I get the larger, the larger diverges also by basic comparison test. Okay, here we go. Excuse me. So let's write this one down. Ooh, there's no number to pull off. But I know between these two terms in the denominator, this is more important, right? This has a more powerful effect. So I'm going to take off an n. So n cubed over n to the 5th. So this has more on the denominator, so this is smaller. And this simplifies to 1 over n squared. So the summation of 1 over n squared, going from 1 to infinity, this converges by p-test, and that's good because that's the larger of the two, so that must mean this converges also by basic comparison test.